We're going to see how to apply sine, the sine ratio, to a triangle if that triangle has no right angles in it. So we are not going to be tying ourselves to opposite over hypotenuse, although we are going to use that to come up with a relationship that'll work for us. And so what we're going to do is we're going to restrict ourselves to SOHCAHTOA, sine equals opposite over hypotenuse, but we don't have any right angles, so there is no hypotenuse. All right, so let's look at this triangle here. The convention that we use in these triangles is that we'll call the corners capital letters A, B, and C. And what we're going to find out is it will be convenient for us if we name the sides with the same letters, but we'll use lowercase so we can tell which ones are the angles and which ones are the sides. So across from angle capital A, if you go across the triangle, that's where you'll find side little a. And across from big B, that's where you find little b, and so on. Across from big C, there's little c. So it doesn't matter which of the corners we call A, B, or C. Whatever whatever angle we call A, little a, the side that we call little a, should be the one on the opposite side of the triangle. If you name a triangle in that way, then the equation that we're going to come up with later is going to be pretty useful. Okay, easier to remember at least. This picture is going to be a picture that we want to do a couple different things with. So I'm going to make a photocopy of it here and put in another copy that we can have over here. So these are the exact same triangle, but once I start drawing on one and then I need to redraw it, I prefer not to have to erase it. So I've just got a photocopy of it over here. All right, right now let's look at this left-hand picture here, and we're going to put a line into that coming out of A so that it comes down and it hits side little a at a right angle. If you remember your vocabulary, that's called an altitude because it comes out of a corner and it hits the opposite side at a right angle. Now that we've got a right angle in there, we could use SOHCAHTOA for this. In order to do that, let's name the length of this side. Something, anything. I'll call it H. Well, then in this left-hand right triangle, H is the opposite side for angle B. If you go across the triangle from angle B, there's H. And because this is the right angle, C is the hypotenuse. So we could write the sine of angle B is H over C. Of course, there's another right triangle over here, and in that one, angle C, this is the opposite, and B is the hypotenuse. So we could write the sine of angle C, capital C, is H over little b. I'm going to solve both of these for H. I'll multiply this one by little c, and get C times the sine of B is H. Over here, if we multiply by little b, we get little b times the sine of big C equals H. Hey, H equals that, but it's the same H for both of them, so those two things must be equal to each other, and now we can eliminate H. C times the sine of big B must equal little b times the sine of big C. And for no reason other than the fact that I know it's going to make our life a little easier, I'm going to divide both sides by B and by C. Little b and little c. Of course, on the left side, the c's cancel, and on the right side, the b's cancel. And what we're left with then is that the sine of b, sine of big B, when I'm out of room here, I'm gonna, oh gosh, I don't know, I'm gonna put it up top. I'm gonna come up top here. The sine of big B divided by little b is equal to the sine of big C divided by little c. That's what we got here when we divided by BC. All right, I want to do the same idea over here on the other triangle, but instead of drawing an altitude that comes out of A, I'm going to draw an altitude that comes out of B. So let's get a line that comes out of B and hits side little b at something that looks like a 90-degree angle, maybe about there-ish. All right, so that's a right angle. That's a right angle. Two right triangles. This top one, oh, wait, we got to name this altitude. I used H before, I'll use W. That's W. All right, W is the opposite side from angle A in this triangle, and C is the hypotenuse. Sine of angle A equals W over little c. In the other triangle, W is across from angle C, and A is the hypotenuse. So the sine of big C equals W over A. Solving both of them for W, I'll multiply by C here. C times the sine of A equals W. Multiplied by little a here, A times the sine of big C, that equals W. Then, they both equal W, so they got to equal each other. C times the sine of A must equal A times the sine of C. And you probably know what's going to happen next here. We're going to divide both sides by little a and little c. On the left, the c's cancel. On the right, the a's cancel. And so what we're left with, I'll put it up the top since I put the other one up top, is the sine of angle A divided by little a is equal to the sine of angle C divided by little c. But remember, these are actually the same triangle. I photocopied this triangle. So the angle C that we're talking about in this right triangle and the side little c, it's the same angle C and little c that we had in the left triangle, because those are really the same triangle, which means this ratio and that ratio are equal to each other. And if sine of B over B equals that ratio and sine of A over A equals that ratio, then all three of these ratios have to be the same. And what we find out is the sine of A divided by the side across from it, little a, and the sine of B divided by the side across from it, and the sine of C divided by the side across from it, all have to be equal to each other. This law is called the law of sines. Now, we may have gotten this by using SOHCAHTOA, opposite adjacent hypotenuse, but now that we've got this equation, we never have to use SOHCAHTOA again. We never have to draw these lines in again. We can just use this equation. Say we've got, in a minute or so here, say we've got a triangle. I don't want it to be an isosceles triangle, so we will get rid of that and draw one by hand. One last try here. That looks awfully right angle-ish, but we're going to go with it. If this angle right here is, even though it looks 90, we'll say it's 85 degrees. And this angle down here is, gosh, I don't know, maybe that's 62 degrees. And this side over here is 13 units long, inches, feet, whatever. But I don't know how long that one is. And I don't know how long that one is. Well, because I know two of the angles, I really know all three. These two angles add up to 147, which means I've got 33 degrees left to put in that angle. And now my law of sines says the sine of 85 degrees divided by the side that's across from it, which is y, has to equal the sine of 62 degrees divided by the side across from it, which is 13. And that's also equal to the sine of 33 degrees divided by the side across from it, which is x. We may have three equations, but what we've really got are two fish problems. There's one of them. Sine of 85 times 13 divided by the sine of 62, that's going to give me y. There's the other one. Sine of 33 times 13 divided by the sine of 62, that's going to give me x. And if we type both of those into our calculator, we have solved this triangle using sine, even though there are no right angles, so we can't use SOHCAHTOA. I'm hitting the 12-minute mark, so we're stopping right there.